Hello everyone, my name is Steven Martinez, and today we'll be discussing the topic of dimensional analysis. So, what better way to begin with describing what dimensional analysis is and how it is used. So basically, dimensional analysis is taking any unit of measurement, whether it be centimeters, inches, millimeters, and converting it to another type of unit of measurement, going from centimeters to inches or inches to millimeters. Regardless, all can be used and found through dimensional analysis. Specifically today, we'll be talking about how to convert grams to moles, moles to grams, and grams to atoms. All three will be discussed in detail and shown step by step on how to solve them. So, let's start with our grams to moles equation. So, let's say we have 45 grams, write this down here, 45 grams of nitrogen. And we want to convert that to moles. So, we want to find how many moles of nitrogen are in 45 grams of the substance. So we take our 45 and we plug it in to our T chart, which looks like this. Basically a T. So we take whatever you're given at the beginning of the problem and put it in the top left corner. So we were given 45 grams of nitrogen, and we want to convert to moles. So you put whatever you're converting to in the top right section, moles. And you want to get rid of grams, so to convert to moles, so you have to divide by what you already have. So we already have grams, we're going to divide by grams to get rid of it, so grams goes in the bottom right corner. What goes here, you might ask? Well, easy. Since we're converting to moles, we want to start with 1 mole. So for every 1 mole, there's a certain amount of grams of nitrogen. So in order to find how many grams are in 1 mole of nitrogen, we go to our periodic table. We find nitrogen, and we find that the atomic mass of nitrogen is 17.0079 grams per mole. So for every 1 mole, there's 17.0079 grams of nitrogen. So now that we have all the spots filled out that we need to fill out, we can solve the problem. So, first step we do is we multiply across. So we multiply 45 by 1 to get 45. Because anything times 1 is itself. Easy enough? So we have 45 now over 17.0079. The grams canceled out in the previous. Canceled out grams, converted to moles, and now we're dividing to get the correct calculation of how many moles are in 45 grams of nitrogen. So 45 divided by 17.0079 is, let me grab my handy dandy calculator over here. Let's plug this in the calculator. So 45 divided by 17.0079 equals 2.645. So there are 2.645 moles in 45 grams of nitrogen. And that's how you solve a grams to moles equation. Okay? Now that we know how to do grams to moles, now we can do moles to grams. So, let's say we have 2.5 moles of oxygen. Alright, so 2.5 moles of oxygen. And we want to convert that to grams. So we want to see how many grams of oxygen are in 2.5 moles. Alright, so as stated before, we take the given amount of the substance, so we take 2.5, place it in the top left corner of the chart, and write our values here. So 2.5 moles, and we're converting to grams, so the grams goes up top in the top right corner, and we're going to divide by moles since we want to get rid of it. Now, unlike the previous one, the 1 is going to go on the bottom because we are getting rid of moles, and it's vice versa. So now we need to figure out how many grams of oxygen are in 1 mole. Go to the periodic table, find oxygen, find that its atomic mass is 15.999, indicating that there is 15.99 grams of oxygen per 1 mole. Now that we have the entire chart filled out like last time, we can solve. So, like last time, we multiply across to get 2.5. Oh, well, we cancel by moles too. So cancel out the moles, left with grams. So multiply 2.5 by 15.999 to get the answer of, grab my calculator here. So 2.5 times 15.999 gives us the value of 39.997 over 1. Anything divided by 1 is itself. So there are 39.997 grams in 2.5 moles of oxygen. So now that we know this, we know how to solve a moles to grams equation. Now, we're moving into how to find an equation, grams to atoms. Unlike grams to moles, there is a new aspect added into grams to atoms equations. In order to go from grams to atoms, we must first go to grams to moles, and then from moles to atoms. So let's say we're given 36 grams of hydrogen. 36 grams of hydrogen. So our given, and we're converting to atoms. So we're going to go to atoms. Okay? So we take our given, 36 grams, goes in the top left, like always. We place what we're converting to in the top right, what we're dividing by to get rid of in the bottom right, and we're converting to moles, so 1 goes in the top. And we find that on the periodic table, hydrogen's atomic mass is equal to 1.0079 grams per mole. Now that we know this, we can solve this equation. But now you're wondering what these two boxes are for. Well, since we're converting to atoms, we place atoms over here as our final conversion, and we place what we're going to divide by to get rid of, which is moles. Now, according to Avogadro's number is 6.022 times 10 to the 23rd power, meaning that there are 6.022 times 10 to the 23rd power atoms in 1 mole of a substance. So we know this, now we can place 6.022 times 10 to the 23rd power over 1 mole, because for every 1 mole, there is 6.022 times 10 to the 23rd power atoms. So, now that we have everything filled out, we can solve the equation. So we take 36 grams, cancel out the grams since we're dividing, multiply 36 by 1, which is 36, all over 1.079. Erase this here to get some more space. Alright. So we take 36 over 1.0079, which gives us the value. Well, actually, we can finish it this way. And we have 6.022 times 10 to the 23rd power atoms over 1 mole. Okay, we can go like this. We can multiply across. So we can multiply across like this. So we can do 36 times 6.022, And we're going to leave off the 10 to the third power till later. It'll make it easier when solving these equations to worry about this at the last step. So we're just going to multiply 636 by 6.022, which gives us the value of 216.729, all over, multiply across this way as well. So we get, let me erase this here. Alright, so we get 216.792 over 1.0079, and when we divide that, we get the value of 215.927 times 10 to the 23rd power. This is what I mean by saving it for later. Instead of multiplying it by 10 to the 23rd power in the first place, leave it at the end so that you can multiply this number by it to move the decimal up further, which makes it 21.5092 times 10 to the 24th power, making it in scientific notation and keeping significant figures. So, at the end of the equation, in 36 grams of hydrogen, there's 21.5092 times 10 to the 24th power molecules, particles, or atoms in that amount of substance. And that is how you solve a grams to atoms equation. Now, to recap what we learned that grams can be converted to moles, grams can be converted to atoms, and moles can be converted to grams. All have a relationship to each other, meaning that grams is equal to moles, which is equal to atoms. So, if I have 36 grams, it's equal to so-and-so moles, which is equal to so-and-so atoms, making all of these one ratio and equal to each other. This relationship allows dimensional analysis to be possible and can allow many other conversions to be possible as well. So, I hope you enjoyed this video lesson today. Leave your questions and comments in the bottom, and I hope to see you again soon. Thank you very much.